This is another video that I'm going to go over sketching polynomial functions. So just kind of just an exercise video. I chose an exercise at random for my text and just kind of go over the strategies for doing so, sketching a polynomial function. So we're going to start with basically the basics here. Let's start with our function f, okay? You'll notice right off the bat that we will want to identify a few things about this function, starting with maybe the degree, okay? So we have degree, the highest exponent on an x here happens to be 3, so this is a cubic. Okay, so that would give us an idea of basically the general shape of a cubic, which we know, is in general something like this. Okay, but also some other things. It is odd. Okay, so our degree is odd, and that gives us an indication of end behavior. That is, it either starts down and ends up on the right, or it starts up and ends down. But because it's odd degree, it must be one of these two things where end behavior must be different from how it begins and how it ends. We also know this, the leading coefficient. Applying the leading coefficient test, we've got a positive 3. But we'd say 3 being our leading coefficient, it is positive. So of the two possibilities we just listed above, we know that the one that it must be is this top one here. It must end up and have started down on the left, because if the leading coefficient is positive, then eventually it gets knocked up to positive values. Okay, so moving right along, we've passed the leading coefficient test here. What else do we know about this? Well, the fact of the matter is, because it is degree 3, it can have at most 3 real zeros. So if it doesn't have 3 real zeros, the other possibility is it could have 1, okay? Or 1. But at most 3 real zeros, and it can turn at most. That is, go from negative slope to positive slope or vice versa. Turn at most either 2 or 0 times, okay, or 0, but at most 2 times. We take that by finding the degree and subtracting 1 off of that. That's the maximum number of turning spots. So for example, like this up here would turn around. It was going uphill, then downhill, then uphill, or it could just be it never turns around. It could be something like this. Okay, so these things being listed, the next things we'll want to find are some intercepts, and the easiest intercept to find would be the y-intercept. And the reason behind that, sorry, my phone just went off. The reasoning behind that is because we can just plug in 0 for x. Okay, so plugging in 0 for x, we find f of 0. Turns out that when we plug in 0 for x, f of 0 actually turns out to be 0. So it does pass through the origin. And that's kind of nice because we're about to find all the x-intercepts as well. Okay, so in terms of x-intercepts, we have a y-intercept. To find x-intercepts, we'll set y equal to 0. So in this case, we're going to have to do a little bit of algebra. But we've got 0 equals 3x cubed minus 15x squared plus 18x. So we'll solve this by factoring, and you might notice right off the bat the greatest common factor on the right side of this equation happens to be a 3 and an x. So if we factor out a 3x, we have left on the inside here x squared minus 5x plus 6, which is itself factorable. So we're going to go ahead and factor it. So we have 3x. Okay, so 0 equals 3x times these two factors, and of course, two numbers that would give us a product of 6. Product of 6 here, but a sum of negative 5, okay, that would be a negative 2 and a negative 3. So now that we've got these, we could indicate that either 3x was 0, or x minus 2 was 0, or x minus 3 is 0. And allowing all those to equal 0, we turn out that our x-intercept happened to be 0. Of course, we knew this when we found our y-intercept, that it passed through the origin. Positive 2 and positive 3. So let's go ahead and start sketching our graph. Okay. Sorry, things just go faster with sound effects, I think. So starting with the things we know. Well, we knew our end behavior, it must start down here and end up is the nature of our end behavior here. We also know that we have 3 x-intercepts. We have 1 at 0. So 1, 2, we've got 1 at 2, and we've also got 1 at 3. So, like in my last video where we went over sketching polynomials, I just kind of want to point out here, what we're doing now is kind of splitting up the x-axis into these intervals, okay? Where every 0 kind of separates the different intervals, but we'd say, okay, so from negative infinity up to but not including 0, from 0 up to but not including 2, and from 2 not including 2 up to 3, and then here on out. Okay, we're going to test an x value from each one of these intervals just to kind of get an idea of where our graph would be located. Okay, so keeping that in mind, what we'll do is we'll select x values that are very, very convenient. So starting with, say, -1 right here. We could plug in -1 into our function. So f of -1, we get, well, for the sake of simplicity, I'm gonna draw this in here. Cubed minus 15 blank squared plus 18 times this here. And let's say we plugged in -1. So -1 would go in this instance here. So -1, -1, -1. And so it turns out in this case, -1 cubed is -1 times 3 is -3. We get -15 times a +1, so +15. And then 18 times a -1 is -18. So what you end up with in this instance, it seems to me, would be, let's see here, 12 minus 18 is -6. So at -1 over here, okay, at -1 we end up with a y value or an output of -6. So we go down 1, 2, 3, 4, 5, 6. So we've got a point here. And so we kind of got an idea that our graph is already proceeding up through here. So now, I mean, we could even say, I think it's going to do something like this. And I know it does. It's just that we, however, want to be accurate. We want to be, accurate. That is okay. So let's plug in, say now, an f value of 1. What about f of 1? So if we put a 1 in all these spots, of course we know that 1 times anything is itself, and 1 to any power is 1. So really we get like 3 minus 15 plus 18. So in this case we get -12 plus a +18, and we also get 6. Okay, so we get 6, +6. So let me get all this out of here. We get a +6. So the y value of 1, we end up 2, 3, 4, 5, 6. We're up at a height of 6. So now we've got an idea that our graph is going to do this little ditty here. So at this point, I'd probably plot, like 2.5 in here, and we should. As a matter of fact, though, that's kind of sloppy. I'm going to leave that out for now. Sorry, I just don't have a calculator in front of me, and we can do synthetic substitution, but I haven't done a video on that yet. 3, why don't we plug in 4, just to see how the graph would behave at 4. So 4 cubed, 4 squared, and 4 here. Yikes. So we get 3 times 4 to the third, so what is that? 16, 256. 3 times 256 minus, let's see, 16 times 15. Well, 16 times 16 is 256 minus 15, so 241 minus 241 plus, this was not a good idea, by the way, 64. 64. So I would say that this overwhelmingly comes out to be a positive number. So it's going to be clear up here, clear way up there, 4. But I think we've got a good indication that our graph would do something to this effect. And of course, if we had a calculator, we could supplement this. So just to kind of show you how good of a sketch we got, I'm going to kick it over here to GeoGebra real quick. And we'll plug this function in. We had 3x to the 4th minus 15x to the 3rd plus 18x. And I see I've typed this in properly here. Boom. Okay, so I'll zoom out quite a bit here. But you'll see, oh, I typed this in wrong. I apologize. This was cubic. So 3x to the 3rd power. And we had 15x squared, not to the 3rd. Let's say our end behavior was a little bit off there. 15x squared and then 18x. That's a little bit better. Okay, so now let's kind of go back to where we were. You'll notice that, yes, we did have zeros at 0, 2, and 3. You can obviously see this. We say a y value or an x value of -1. We were clear down here, and I think I calculated that wrong, actually. We should calculate it again. It was -6. Sorry about that. I can go back and annotate this video, but at an x value of 1, we were actually at a height of 6. I didn't biff that one up. And then, if we had plugged in 2.5, it seems we would have been at this y value right here, this relative minimum. But the idea really is this: to find your zeros, find your y-intercept, determine your end behavior graph, and then plug in x values that are between your zeros on the graph to find some arbitrary y values and get a good idea of how your graph looks. So I promise in the next video I will try to do my arithmetic better. But trust me, those would be the steps that you would go through necessarily to determine the nature of your curve before you sketched it. Enjoy!